Okay, so in the last video, I think I said I was going to try and work on the I/O devices for the Fatstacks computer. Uh, Instead, I've been working on refitting the state machine because the last time, in the last model, the state machine was only giving it the control unit basic information, and then the control unit just consisted of a bunch of decoders, which would translate the control information into the actual control signals. This one actually just provides the signals directly, and the reason for that, and the reason for that design idea was um, having those decoders in between the state machine and the actual execution side of the computer meant that I could squeeze in information from the opcode into this information. So instead of the opcode controlling the state machine and having that perform all different functions and such to perform operations with different registers and such, for example, instead I could just have a decoder in between controlling register selection. But of course that's not really necessary here because there's not very many options to choose from. There's only two registers and they're invisible to the programmer, so it doesn't matter. So in this case, I've just taken out the decoders entirely, and it looks pretty good. It's a little bigger, but it does look a bit cleaner. I posted a picture on Twitter of this particular model, and I actually like it. It looks pretty neat. You can pretty easily tell where everything is. The only part that's still a bit messy is this part, but that's to be expected, really. But yeah, so my expectation with moving the I also want to mention the only part I'm not too terribly happy about is I don't have this running. I meant to have it running. We're gonna experience some lag, but I don't care. I'm the only thing I'm not too terribly happy about is these wires, how they're kind of spanning from different parts of the computer into the state machine. Really, what we could do is have these move to them, so that'd make for a nice short run, and I think that would be a little bit more beneficial in terms of speed, but probably only shave a tick or two down. Speaking of speed, that is primarily what I've been focusing on with this particular update here. What I mean by that is my expectation with removing the control ROMs or control decoders over there was that I could effectively increase the performance speed, because instead of having to go through a decoder, I could go directly to the computer. And I guess it did increase the speed a little bit. I was able to shave about 2 ticks off of the clock. Now, mind you, the last version I wasn't able to actually clock because I was doing it manually. This was the first one with the clock, and as you can see, there's quite a few repeaters. I think it was like 40, 45 ticks, and I was able to shave about 2 ticks off the entire machine by getting rid of those decoders. So not a huge performance benefit. But here you can actually see that there's about a 25 tick clock rate, which is, I've sliced it in half, and the reason why is because I've actually been going through the entire computer system and tuning everything. This is probably the first time that I've ever put this much effort into making sure the timing of a computer was very, very well tuned. I'm usually not too terribly concerned about that, but I feel like my computer building skills has sophisticated quite a bit over the past few revisions, and so we're no longer focusing on just making it work. We're focusing on making it work fast. And I had also deeply, deeply considered somehow implementing a pipeline into this thing to make it work even faster. I honestly have no idea how, because it's each instruction can access memory up to 4 times, and you can't pipeline that. Not easily, anyway. I suppose you could with the command block RAM module. You could have multiple pointers. That wouldn't be too bad of an idea, but I'm trying to build this in such a manner that it can work with more traditional actual redstone memory, which of course, now that that's another thing that I need to bring up, is now that I've got everything tuned, this is all tuned to that memory module, which is basically instant, and it's also a uniform amount of time regardless of where in memory you're accessing, whereas this, there's quite a bit of a delay and obviously the further back in memory you access, the longer it's going to take. So that's probably going to slow down the computer a little bit more. But the primary thing that I did to actually adjust the clock speed of this thing is just getting the disable and update lines properly tuned. So I can show you what I did in the last one. And the last one I think is, I actually haven't looked at it, but I think it's fairly similar to this. Let's see. So here it's basically just a case of the line disables everything so that the signal is, or the control signal coming from the state machine is basically null. Then it is updated and then it is enabled. So it basically goes from the previous control signal to null to the next control signal. Well, the way I had that set up before and the way I had that set up for this as well was that enable signal is just hooked directly up to the clock. And so for half the cycle, the instructions were disabled, and for the other half of the cycle, that was the only time when instructions were actually being executed, or control lines were actually being sent, I should say. I don't know. So what I did, and obviously, you know, this is something extremely obvious, but I actually didn't think of it until just recently. But I basically put in a monostable circuit into the enable disable line. So instead of the instruction being disabled for half the cycle, it's actually disabled for only a few ticks, and that means that more time can be allocated to actually executing the instruction, which means we could, in fact, make our clock speed a lot faster. So that definitely has helped, but one of the biggest drawbacks that I'm running to now is the amount of time it takes to actually calculate the address. That is really loud. Turn that down just a hair. So basically, when it comes to the address, normally this would just be coming from a register. Even more normally, it would be coming from program memory, but we're doing it this way because we can. Normally, it would be coming directly from the register, and that would pretty much be it. There wouldn't really be much of a delay, but these things are dropping down to 30 FPS, good lord. These things are going through, let's see, we got one adder for, I'd have to go over the schematics. Really should have pulled this up. One adder for the loops address thing, another adder for the incrementer decrementer. We've got a multiplexer. I think there's a third adder in here, or maybe I'm just making stuff up. I don't know. But the point is, it's going through quite a few circuits to actually calculate the address before it actually gets to the address bus. And so that's normally not a problem. But then you also have to take into consideration that you have to wait for the address to stabilize before you can actually read. And then you need to wait for your information to stabilize from memory to actually write. And of course, it works the same way the other way around. You have to wait for your source information to stabilize before you can write to memory. I suppose in that case it's not nearly as severe because you can generate the address and stabilize your source at the same time, but accessing memory reads is a little more sequential, so you have to wait for the memory to, or the address to stabilize before you can read from memory. So that's one of the reasons why it's so bloody slow. And then the other part is, obviously this thing is quite long. That's probably contributing to the amount of time it takes for data to flow, because we pretty much have to wait for data when it's being read to make its way through the entire computer and at least get to about here, I think, before we can actually write. And that's quite a long path. And of course you're going through the ALU, so that only adds more of a delay. Point is, I think if we can shrinkify the computer a little bit more, that might increase speed a little bit. Of course, the biggest factor is just the amount of circuits that the address has to go through. Wow, that's laggy. The amount of circuits that the address has to go through before an address can actually be created. So if I can figure out a way of getting all the functions that I need out of this circuit while also decreasing the amount of time it takes to actually perform those functions, I think we would be on the right track to speeding this thing up. But all in all, yeah, I think this is the first time, like I said, that I've put this much effort into tuning a computer and getting it to run quickly. Um, and I also don't think I've tested all of the instructions. I've basically just been running the Fibonacci. This has been my benchmark, making sure that it actually runs. And if I can actually get a Fibonacci sequence to appear on the popped stack here, which is what you're looking at right now, then it's a good indicator that it's working. So that's pretty much what I've been doing. I know there's one instruction that I haven't tested that I know is probably buggy, and that's the skip instruction, or the jump if equal, not equal, all those things. I have confidence that it'll branch properly because these are all tested circuits. I know they work. The issue is that it doesn't, or it adds 1 to the address when it's actually branching, so it ends up skipping 2 instructions. It's kind of weird, but yeah, it's an easy fix. In fact, I think all I have to do is just get this to subtract 1 from whatever is coming from the loops and register. So it's not too big of a deal. But other than that, it does, in fact, work. I suppose one of the other things that's causing the delay in the address is just the fact that I also don't have any of the address circuit control lines synchronized. So it could very well be that because there's only like 1 tick of delay between this control line and the read line for the register, and there's like 3 or 4 ticks of delay between this control line and the subtract system here, it might very well be that that's also causing the delay. Because one of the things that I've been noticing is when subtracting, or decrementing, I should say, it'll do just that. You saw what it did there. It'll sit here and flicker for a little bit and then stabilize. So I'm guessing, synchronizing these control signals a little bit more effectively would probably eliminate that. Otherwise, I think generally just the entire computer could use a synchronization check just to make sure that everything is going through at the exact same time. Might help with stability, might not. If I had to guess, I'd probably shave off maybe 4 or 5 ticks. I don't know for sure, though, because, I honestly thought that taking out those decoders would shave off a lot more than it did, and it didn't. Yeah. Otherwise, I think the project is coming along quite nicely. Now, obviously this is a learning experience. I think this is a true and proper state machine controlled computer, and I think it looks great. I think it works pretty damn well. I think, though, we might be switching to pipeline computers sooner than later, just because I'm really eager to start making something that can actually perform fairly quickly, because, this is nice, but it's not nearly as fast as I'd like it to be. Albeit this is, again, probably one of the faster models that I've created, but I think I've said that about everything. I don't think it's as fast as Deep Thought, but then again, Deep Thought was a simpler computer. You could argue this was also simple, but I don't know. It seems a little bit more robust and versatile than Deep Thought. But nonetheless, I figured I'd share a quick update to keep the content gremlins happy, or at least just let you guys know that I'm still alive and still working on these things. I'm probably deeply considering releasing another Let's Play video. I know it's not really my most popular video series, but it's something that I enjoy doing, and I have been doing stuff in the world. And it would probably be a nice little filler between this and the part 4 for the tutorial series. So those are just some thoughts I wanted to share. Other than that, that's my update for the Fatstacks machine. And I will see you guys when I have another one. Hopefully in the next video we'll actually have I.O., or I'm probably just going to be doing more tuning. We'll see. But yeah, I'll see you guys in the next video.